Hello to everyone. So this is an just introduction for thermodynamics. So let's see, what can I tell you about thermodynamics? So thermodynamics is basically two words combined in one. So the first one will be called thermo, and the second one dynamics. So thermo, this first term, is related to heat, which you will see later on that generally is defined by the letter Q. And dynamics is basically the study of the motion. But basically, if you needed to give one equation for dynamics, that equation will be summation of forces equals to ma. And you will see that the starting equation for all the derivations will be that one. All right, so the first, maybe to understand that the term thermodynamics is pretty new. It wasn't really introduced until the 19th century, actually, on 1854 by Lord Kelvin. And Lord Kelvin, his real name was William Thomson, but he was basically a noble in England, so he had the title of Lord Kelvin. And Lord Kelvin, basically in one of his works, was the first one to use the term thermodynamics. Okay, but before that, it was other people that started to think about the effects of heat. So all the problems go all the way back to the Greek, Aristotle, Socrates, and so on, but my goal here is not to give a history class, but an engineering class. So maybe let's go just to more recent events, and probably on the 17th century. What's happening on the 17th century? So the first event probably was on 1656. Two scientists, Boyle and Hooke, basically observed and gave the equation that says that the product of the pressure and the volume is equal to a constant. So that was maybe the first big equation that we can relate for thermodynamics. So using that information, and later on, a French engineer called Guy-Lussac, basically using that information and using the fact that they just developed the thermometers in order to quantify the heat, was able to write the equation as is nowadays known as the ideal gas constant equation, which basically means PV will be equal to nRT, where P is the volume, again P is the pressure, V is the volume, N is the number of moles, R is the gas constant, and T would be the temperature. And this equation, probably you have used it in chemistry a lot. All right, so from there on, what happened? Okay, now let's go to a bit more engineering. So now we go to another scientist called Denis Papin in 1679. So what did he do? Really, what he did is mention on his work something that he called the bone digester, but in simple words, it's just a pressure cooker. So basically, you have the water over here with the bones, everything was being heated, okay, here by the fire, and his big discovery here actually is a little thing here on the top side, which is basically the release valve. So by adding a release valve, he was able to control basically the amount of pressure inside the pot, and without the pot having to, without the pot exploding. Okay, so the observation of the little valve going up and down as he was releasing pressure gave him the idea, and he was the first one defining the idea of a piston moving up and down. Okay. So like in many events in life, he's not the first one to observe an event that is able to get the full purpose out of it. So here the same thing happened. So it's in England, somebody that was following the work called Thomas Savery, basically based on Papin observation about the piston, is the first one that really built the first engine, and the first engine will be a steam engine. Okay. All right, so that wasn't really the first engine. There were other ones, so maybe we can talk about them. So it was the Thomas Savery engine, about the same, so basically just small improvement. Then you had the Newcomen, engine, and another one will be the Watt engine. So you see that Watt is a unit, so it's very well known. Newcomen is also very well known. But basically those were the first engines. So since I talked about this first engine, what was really the first applications of these engines? So some people think that maybe the first and most important application was steam locomotive, or that the people were really interested in moving in cars, locomotive. Now, really the main problem in that time was mining. So either salt mines or just coal mines. So maybe even nowadays, if you go on any construction site, they always have some type of pumping water out of a hole in order that they're able to put the foundation or to do some work. So imagine in the mines, basically you always have water leaking into the different alleys or inside the mine. So the main problem was always to remove the water. So the way it was done before basically is that they had a horse that was turning around, or a cow, or a bull, and attached with buckets, and then the buckets would go down, up and down the mine, and they will do so. All these new engines, really the first application were for mining, but they were extremely inefficient. So generally the efficiency of any of these engine was of the order of 2%. So basically what does that mean? Is that they had to burn a lot of wood or coal in order to get very little out of it. All right, but that rapidly changed. But basically this problem, and because this was a big industry, a lot of money was involved, that pushed many of the scientists to start working on this issue and to try to find a solution by developing new engines. Okay, so maybe one of the first one that is known as one of the fathers of thermodynamics is Carnot. So it's one of the fathers of thermodynamics. So you will see later on there are different Carnot principles, but basically what he did, and that was around 1824, is the first one that actually introduced the term work. So basically it was saying that you can obtain work from heat. Okay, or is the first one that related work actually to the actual definition, which is force times distance. Okay, and really from this point on, you will have obviously Kelvin, that was extremely important, that will develop a lot of the rest of the theory. Okay, so one last thing I want to mention over here is that really thermodynamics in most cases is basically, let's say we are, so let's think about something. Okay, what do we do in thermodynamics? So the classic example will be, let's say you have in a pot, you have water. So you are heating the water over here with whatever you want, some type of flame. So what's happening? As you heat the water, you're going to have water over here. Then it's going to start to heat up, but some water will become steam. Some water remain liquid. And as the heat is being transferred into the pot and into the water. So this will be again our Q. So the main problem of thermodynamics is, or the first problem of thermodynamics will be to be able to define what is the state of the substance water. Okay, so what could be the state? State could be for the water. Water, you can find it in a liquid state, you can find it on the steam state, but you also know that you could find it on a solid state, which it would be the ice. So one problem of thermodynamics is what is the way to define the state of a substance. So for example, water, is it in state liquid, gas, that will be steam, or solid, that will be ice. And the other way is that it will be different ways on how the heat is being transferred by the source of heat into the water. And that is called really heat transfer. It's a whole class, but we do a little bit in this in this course. And the three ways to transfer heat will be conduction, which this one is a good example. So basically the heat is first going through the solid medium of the pot. Okay, so that would be conduction related to a solid medium. Then we could have convection. So convection now will be, if you want, how you transfer the heat between the surface of the pot and the water. So basically the water is liquid, so it will be a fluid medium. So if you want an easier example, will be the fan in a house. What is the function of the fan? Is to increase the motion of the air so it can remove faster the heat from your body. Okay, here you think when you look at water boiling, you will see that because the bottom is hotter than the top, you will see actually a motion of the water doing this. The lighter hot water will go up, the colder water will go down until it starts boiling. Okay, and the last one will be radiation. So radiation, this one will be related to a wave. And you can just think about the microwave, or you can just think about how do Earth receive the heat from the sun. Okay, and I think that should be it for this first introduction video. So I will stop now the video over here.